Hi Math 2E. Let's look at some graphing. So first off, I'm going to graph a cosine graph in number 1. Now I know my cosine graphs start at its max because at zero, cosine has a value of 1. And then I know that I'm using my unit circle values, so pi over 2, pi, 3 pi over 2, and 2 pi. This is one period or one cycle of cosine. And I know at pi over 2, my cosine or my x-coordinate is 0. And at pi, my cosine or my x-coordinate is -1. 3 pi over 2, I'm back to 0. And at 2 pi, I'm back to 1. So when I'm above my midline is this theta axis. It divides my graph kind of in the middle. I'm concave down. So I'm going to concave down. When I'm under the midline, I'm concave up. And this is -1 down here. And then when I'm going up here, I'm still concave up. And when I'm above my midline, I'm concave down. It's sort of this little shape right here that I have. So that's my basic cosine graph, y equals cosine of theta. So in the graph I'm trying to do, my midline is going to go up 2 because 2 is my vertical shift. So I'm going to go up to 2 and I'm going to draw a new midline. And when I draw my max and min, my amplitude is 1/2. So instead of going 1 above and 1 below my midline, let me get a different color here. My graph, instead of going 1 unit, instead of going 1 unit above, 1 unit below, 1 unit above for my maxes and mins, I'm only going to go half a unit because my A is a half. So I'm going to start at my max, which is going to be a half a unit above 2, or at 2.5. And then at pi, I'm going to come back down to my mid unit, concave down. And then at pi, I'm going to come down to my min, which is at 1.5, half a unit below my midline. And then at 3.2, I'm going to come back up to my midline. And at 2 pi, I'm going to be back up at my max. Oh, that was kind of high, actually. So I get a little graph like this. This graph is very shallow. It's vertically compressed. Vertically compressed. And that's because my A is 1/2. My maxes and mins are only half a unit above my midline. Now this is one period of pi. A period is how long it takes to do one cycle, max to my minimum back to a max. But cosine does go on forever. So for example, at 5 pi over 2, I'd be coming back down to my midline. At 3 pi, I'd be 1/2 unit below. And then I'd be coming back up to my midline and going half a unit above. And over here, I'd be coming back down to my midline, going half a unit below, coming back up. So I'm going to just put some arrows there because cosine goes on forever. So in this graph, my domain is actually -infinity to infinity. Now, if you only draw the portion from 0 to 2 pi and you say the graph domain is 0 to 2 pi with brackets, that is true for what you've drawn. But the function itself oscillates forever. That's why I have all real numbers here. And my range is going between 1.5 and 2.5. I do want to clarify, I don't know where to get to my eraser, but this guy is only supposed to be going through a half. I think I just drew it a little bit tall. Kind of looks like it's going up to 3, but it's only at 2.5. It's only half a unit above. Half a unit above, half a unit below, half a unit above, half a unit below. My amplitude is 1/2. So now let's take a look at the second one. It's a sine graph. So my sine graphs at 0, this is my theta axis, and I'm going to write my unit circle, my unit circle values here. At 0, my sine function is 0. My y-coordinate is 0. At pi over 2, my y-coordinate, which is sine, is 1. At pi, I'm back to 0. At 3 pi over 2, I'm negative 1. And at 2 pi, I'm back to 0. So my sine, or my y-coordinates, when I graph them, I get this graph right here. So sine always starts at its 0, or sine always starts at its midline. So when I get ready to do 2, I notice I have a vertical shift again. It's k. So I'm going to go up to 2, and now I have my midline again. And I also have an amplitude of 2. So this time, instead of being 1 unit above, 1 unit below, I'm going to be 2 units above and 2 units below, because my amplitude is 2. So I'm going to start at my midline, which is my new 0. And at pi over 2, I'm going to be at my max, which should be 2 units above my midline. At pi, I should be back to my midline, which is my 0. At 3 pi over 2, I should be at my minimum, which is 2 units below my midline. And at 2 pi, I should be back to my midline. So these shouldn't look so pointy. It's definitely a curve. Sorry, I'm drawing with this Apple pencil. And so that is one period. Remember, we talked about a period. One cycle of pi from 0 to 2 pi. That period is 2 pi. But remember, sine sort of oscillates and goes on forever. So technically, there's an arrow there going up, and this is going back down to a min. And so my domain is all real numbers, or negative infinity to infinity. And my range for this problem, my lowest y value is 0, and my greatest y value is 4. So my range is 0 to 4 with brackets, because at 0 and at 4, my graph exists there and is solid. So now tangent. Tangent, you're going to have 2 more chances to do tangent on the next page, but tangent has 2 asymptotes to begin with. At pi over 2 and at 3 pi over 2, my tangent graph has a value of undefined. So that's where I would have a asymptote, a vertical asymptote where my graph is undefined. Now you'll notice at 0 and at pi and at 2 pi, the value of tangent, or y divided by x, is 0. And so this is where my curve is going to cross my theta axis. So now, what is it doing before? So my curve is sliding down its asymptote, and it's coming over here and bending and coming down the other side. So how does this graph bend? Well, at 5 pi over 4 and at 3 pi over 4, the value of my tangent is 1 unit and negative 1 unit. That's my y-coordinate divided by my x-coordinate. So that's why it's sort of doing this bend. It's sliding through 1, sliding through 0, sliding through 1, and coming out the other side. Tangent, this is what the tangent graph looks like. Tangent graph has a period of pi. That's because from 1/2 to 3 pi is just plus 1 pi. That's 1 pi unit. It's like 1/2 to 3/2. It's 1 unit. It's 1 pi unit. So my period. So this is what my graph does over and over. So if I ask you to draw the graph from 0 to 2 pi, like if that's what it says, then that means that you would have another portion on top here, and you would have another portion on the bottom there. That's me drawing my tangent graph from 0 to 2 pi done. That's what would have to be graphed. But a lot of kids finish off this curve, and they finish off this curve right here. So when I grade your tangent, I'm looking for these vertical asymptotes, your dashed lines. I'm looking for your 0. I'm looking for this smooth bend, if you will. That doesn't look very smooth, sorry. This is much smoother right here, and this is much smoother. So that's sort of what I'm grading. I actually don't really look for this one and this one, but technically you can kind of almost see them on my graph, like it's going through those points when I'm doing that little bend right there. And that would be my tangent graph. That's what tangent looks like. On the next side, we'll do a couple more tangent graphs. But let's take a break from tangent and let's look at secant, cosecant, and cotangent graphs. So we're going to give you this little first quadrant of the unit circle, and then hopefully you can get to your other coordinates you need. Like for example, at number 4, I'm doing secant of 7 pi over 4. Well, 7 pi over 4 is in this, in my, So if I make this, 7 pi over 4 is the 45 degree angle in the fourth quadrant. So it's a rad 2 over 2 coordinate. And this is my 7 pi over 4. And I know in the fourth quadrant, my y values are negative. So my sine value is negative, my cosecant is negative, my tangent is negative, my cotangent is negative because my y coordinate is negative and my x coordinate is positive in the fourth quadrant. So I'm going to use the coordinate rad 2 over 2 and negative rad 2 over 2 to do my secant. And I know that secant theta is equal to 1 over cosine, so it's equal to 1 over x. I know that cosecant theta is equal to 1 over sine, so that's 1 over y. And I know that cotangent theta is equal to the inverse of tangent, or x over y. So this becomes 1 over my x coordinate, which is positive rad 2 over 2. That's 1 times the reciprocal. So I'm getting 2 over rad 2. But I can't stop there because that needs to be rationalized. So I'm going to multiply by rad 2 over rad 2. And when I do that, I get 2 rad 2 over the square root of 4, which is 2. And my 2's cancel. And I kind of ran out of room. So I'm just going to put a box around my square root of 2 because that's my answer. So now let's do cosecant of 330. 330, well, that's 30 degrees before 360. It's the 30 degree angle in my fourth quadrant. That's where 330 degrees is. So this is my rad 3 over 2 1/2 coordinate in the fourth quadrant. And in the fourth quadrant, my y's are negative. So when I'm doing my cosecant, I'm going to be using this rad 3 over 2 negative 1/2 coordinate. And cosecant is 1 over my y value. So this is 1 over negative 1/2. I'm going to multiply by my reciprocal, which is negative 2 over 1. And I'm getting negative 2 for my answer for cosecant of 330. Cotangent of 3 pi over 4. So 3 pi over 4 is actually in my second quadrant. And my I can't really write on it over there. But in my second quadrant, my x's are negative and my y's are positive. And this is my 45 degree angle. So I know it is my rad 2 over 2 coordinate. And my x is negative and my y is positive because this is in the second quadrant. So cotangent is my x, negative rad 2 over 2, divided by my y, positive rad 2 over 2. So this is a negative divided by a positive, which is negative, and the rad 2 over 2 cancels itself. So I'm just getting negative 1. Cotangent of 300. So 300 is 30 degrees after 270. So I know that is my 60 degree angle in the 300 is my 60 degree angle in the fourth quadrant. So it's my 1/2 and my rad 3 over 2 angle. And in the fourth quadrant, my y's are negative. So cotangent, again, is my x coordinate, which is positive 1/2, divided by my y coordinate, which is negative rad 3 over 2. And that gives me 1/2 times 2 over the square root of 3, and that's negative, and my 2's cancel. So I get negative 1 over the square root of 3, which I need to rationalize. I'm going to multiply the top and bottom by square root of 3 over square root of 3. And I'm running out of room, so I'm going to come down here. So that's the square root of 3 over negative square root of 3 over square root of 9, which is 3. So I'm getting negative rad 3 over 3. Sorry, this isn't the neatest work. I hope you can follow everything okay. So let's go take a look at our next page. The top of our next page is 2 tangent graphs, but I'm actually going to change, just to help you guys understand a little better, I'm going to change 8 to 3 tangent theta plus 1. So I know what tangent looks like from doing it on the other page. I know I'm going to put my asymptotes on here at pi over 2 and 3 pi over 2. And this is my vertical shift of plus 1. So I'm going to put a new midline on here at 1. This is my new midline. It's like my new 0. And I know tangent is 0, at pi, and at 2 pi. So on this brand new midline, I'm going to put my zeros on. Now, what is this 3 doing? Well, if you remember, and I'm going to erase this, so I'm not going to put it on very dark. If you remember, on either side of my 0, my tangent graph is at 1 and -1, and that's how I would draw my bend. But when I have an A, this A value is 3. When I have an A, that multiplies my 1 and -1 value. It's really 3 and -3. It's really 3 above and 3 below my midline is where my bend starts. So actually, at 5 pi over 4, I'm going to count up 3 above my midline. 1, 2, 3. And so I'm going to get rid of, don't I have an eraser? I think I do. Try. Okay. And then now I'm going to count 3 below my midline. 1, 2, 3. So my bendiness actually starts sooner. So as I draw this, I don't have such an obvious bend. My graph is coming down my asymptote. I go into my bend and it's kind of feeling almost linear-ish, but it's not really linear. I mean, this is a curve. It's just so stretched. Because my A is 3, sorry, that's supposed to be an equal sign. Because my A is 3, this is vertically stretched. So if you can imagine pulling on my tangent curve, I'm like pulling it up a little bit. It is looking a little straighter-ish. That's what happens with the 3. That's what happens with a 2. That's what happens with a 4. Now, if it was a 1/2, if you were doing a problem with a 1/2 in front of it, now that bendy, if this is my 0, it's going to be a little bit more obvious. That's what the 1/2 would do. It would make it a little bit more obvious. But that's not this problem. I'm just kind of talking. So I'm going to let you do number 9 on your own. The answer's in the filled in packet. Make sure, let me go back to 3. So I know from on the right side of my asymptote, it's going down towards a negative infinity. And I know on the left side of my asymptote, it's going up towards positive infinity. So if I had to if it said draw this graph from 0 to 2 pi, I would have to have those 3 parts. Like I said, most kids finish this. So they do something like this with their tangent graph. I'm going to let you do number 9 on your own. Please check your answers in the filled in packet and make sure you're doing it okay. I don't think there's anything too new. Let's do 12 in this section. We looked at 330 on the previous page, and the x-coordinate was rad 3 over 2. So secant 30 would be 1 over cosine, which is 1 over x, which is 1 over rad 3 over 2. And it's positive in the fourth quadrant, the x-coordinate. So I get 1 times the reciprocal, which is 2 over the square root of 3, which is 2 over the square root of 3. So now we are going to rationalize that. And I multiply by rad 3 over rad 3. And in the numerator, I get 2 times the square root of 3. The denominator, I get the square root of 9, which is 3. And so this gives me 2 rad 3 over 3 for my answer. You can do the other 5 problems and make sure you check your answers in our filled in packet. So I believe we did 16 and 18 in class already. So on this part, I'm going to do 17 and 19. If you've not yet done 16 or 18, you could do those and check your answers in our filled in packet. But this is 2 cosine theta, and you could think of this as having a plus 0 behind it. So there's no vertical shift. So my midline is my theta axis. My amplitude in this case is 2, meaning that my max is going to be 2 units above and my min is going to be 2 units below my midline. So I know cosine starts at its max. So I'm going to start it at 2. I know at pi over 2, it's coming down to its midline. At pi, it's at its min. At 3 pi over 2, we're back to its midline. And at 2 pi, I'm back to its max. And when it's above the midline, I have this concave down shape. And when it's below the midline, I have this concave up shape. And that creates my graph. Now, cosine's graph is also really negative infinity to infinity. Now, I would agree in this picture, I've graphed 0 to 2 pi. That's the x's that have been graphed. Like that, if that's how you think of it and write it, I mean, that's not wrong about the way it's graphed. But cosine really goes on forever. It's like these 4 little movements. My next movement is the one coming back down. The movement after that would be the one going down to the min. The movement after that would be the one coming back up. I'm going to just put an arrow on it. So cosine really does go on for all real numbers as far as the domain. The range of it, in this case, my range goes back and forth between -2 and 2. So let's take a look at 19. On 19, this is a sine graph. This sine graph has an amplitude of 1/2 and a vertical shift of -1. So I'm going to go down to -1 and I'm going to draw my new midline. And I know sine starts at its midline. It starts at 0. So it starts at its midline and it goes up to its max. So at pi over 2, my max is only half a unit above my midline. At pi, it's coming back to its midline, which is at 0. At 3 pi over 2, it's going to its min, which is only half a unit below. And at 2 pi, it's coming back up to its 0. And then I would have this graph for sine. And it only is a half a unit above and a half a unit below. So sine keeps going too. So I'm going to come up here and just kind of put an arrow. And I'm going to come down here and put an arrow. And the domain of sine is negative infinity to infinity. And the range in this case, it looks like I'm going back and forth between negative bracket, sorry, it's a bracket, negative 1.5 and negative 0.5, which is really the bigger number. That's why it's second. And negative 1.5 is really the smaller, more negative number. And as a reminder, on the test, it's probably going to be worded that you have to draw the sine from 0 to 2 pi on the theta axis. So I would have to see from this 0 to 2 pi. That's the part I would have to see to get full credit for your graph. I hope this was helpful.